In this segment and those that follow, we'll look at the herd animal class, an intermediate base class between animal and herd animal classes like cow and horse. Along the way, we'll look at collection classes, iterators, and lots of other object-oriented concepts. Now, herd animals in our simulation move by following animal behavior if they have not found a leader, but on each step they also search for a leader to follow, and once they found one, they follow that leader in lockstep from then on. This behavior is common to classes like cow and horse. Instead of duplicating that logic in each herd animal class, we'll create a common base class, herd animal. There's code for it here, that derives from animal, as you can see right there. By the way, don't worry about the abstract in the class declaration just yet. We'll get to that a little bit later. Now, we'll put into herd animal all the code that is common to any herd-forming animal, leaving only the cow and horse specific behavior to go in subclasses cow and horse. And the UML for that is shown right here in the diagram. We even threw in object for completeness. So we have animal extending object and herd animal extending animal, and then we'll have cow and horse in turn extending herd animal. Now, since we'll be doing more and more UML, by the way, now's a good time to hunt up a UML notation chart, either online or in a good UML text like Fowler's UML Distilled. You don't need to understand all the symbols yet. We'll go over them as we go. But do try answering this one question from your chart just to kind of encourage you to look at it right now. UML has a connecting symbol between two classes that represent an association between them. Briefly, that's when two classes have an important relationship, but not a superclass-subclass relationship. What symbol is that? Just check it on your chart. Returning from a pause there, it's a simple line between the two classes. Now, we'll see some association relationships in upcoming lecture segments, along with other UML ideas. Keep a link to your UML chart. So returning to the code for herd animal here, what we'll find is that herd animal has two major parts. At the top is code for keeping track of all existing herd animals and an overridden step that checks all herd animals on the list to see if any is a suitable leader. And we'll cover that portion first. At the bottom, by the way, is logic by which one herd animal follows another, and we'll cover that in the following segments. Now, to look for a leader, a herd animal needs some way to track all the other herd animals in existence. An array of herd animals would be one obvious solution, but we wouldn't know how big to make it in advance. You'd have to set some initial fixed size and then fill the array as new herd animal objects were created, resizing it, I suppose, by copying it into a larger array when needed, as we did for the prime set example. This would be pretty tedious, but Java provides a library class, ArrayList, that does that job automatically. It's part of the Java collection classes, which we'll cover deeply later. An object of ArrayList has an internal object array of its contents, and then methods like go, remove, and get, and size to get or remove an item from that internal array, to return how many items there are in it, how many objects there are in it. The iterator method is something we'll look at a little later. You can look up the details in the Java docs and get a full list of all the methods. Now, ArrayList also does any necessary array resizing automatically. We don't have to worry about it. So we declare and allocate an ArrayList all member up here in the code for herd animal to hold references to all existing herd animals. And in the herd animal constructor, right there, we add each newly created herd animal to all as the herd animal is constructed. And question 2. All is a list of object. How can it hold herd animals? Asking that in another way, assigning a herd animal to an object reference is an example of, looking for a term here, after a pause, a herd animal is an object. Object references can point to any type of object. Assigning a herd animal to an object reference is upcasting. But note, when we retrieve anything from all, it will be returned as an object reference. It'll really point to a herd animal, of course, but we'll have to downcast it into a herd animal reference. Question 3. Okay, but is there anything stopping me from adding, say, a string or maybe a vector to all? What if I put a vector here instead of this, for example? Just to kind of mix things up a little bit in the list and have different kinds of things. Returning from a pause. No, there's nothing at all to prevent that. It's probably a bad idea, but you can do that. Again, any object can be added to the array list. But when it comes time to retrieve the object and downcast the object reference, you better know what type it is. And so question 4 here, or you'll get what? What is going to happen if you downcast badly when you retrieve an item from array list? And when will it happen? Sorry, by the way, for repetition, but this stuff is so critical it's worth reinforcing. Returning from a pause. Hopefully this is just review. You'll get a class cast exception at runtime. We showed that in a prior lecture. Now, the idea that a list or array could contain a variety of things takes some getting used to if you haven't seen it before. There's a term for this idea. Array list is a heterogeneous collection, a collection coming from different types. In practice, do you actually put a lot of different types in a heterogeneous collection like array list? Yeah, but it's usually not a hodgepodge of strings and vectors. Instead, it is common to put different types in such a collection as long as they share the same superclass, other than just object. Why this is useful will be clear later. For the time being, the only thing we're going to put in all is herd animals. And while we're on the subject, by the way, the generics feature of Java lets you impose a certain base class type, like herd animal, on an array list or other collection. We'll use generics later in the herd animal class, but generics are a relatively recent addition to Java, and you'll find older code that doesn't use them, so it's worth doing one example without them, and that is our array list all. Question 5. Why does it make sense for all to be static, given its stated purpose? What would happen if it were an instance member? Be precise. How many herd animals would it contain? What would they be, etc.? Remember that it's filled in by this all.add command in the constructor. Returning from a pause there. Well, if it's a shared list of all the existing herd animals, which each herd animal adds itself to as it's constructed, there should be only one copy of such a list. And if we made all an instance member instead, then every herd animal would have its own copy, which would be initially empty, and then it would add itself to that copy as the only member. And we'd have a bunch of one item all instance members, one in each herd animal. And that's not too useful. We want a single paired list instead. Thus. Now that we have a list of all the herd animals, what methods in animal need to change in order to search that list for a leader on every step? And how do we make that change? So peruse animal, you should have a source copy of your own as well, and figure out what we need to change in here to make it look for a leader on each step. Returning from a pause, aside from the constructor to add the new animal to the list, the only method that needs to change is step. Everything else in animal can remain as is. We need to override step, then, in herd animal, as we do right here. Now this herd animal step override is a lot different from animals step. First, we do nothing if the herd animal has a leader, which would be pointed to by my leader. Once it has a leader, a herd animal is on autopilot in lockstep with its leader, using code we'll look at later. The step method is effectively turned off. But if we don't have a leader, then we first make a conventional step by calling our superclass version, this time in the middle of the code. Then we call lead followers to cause any followers to mirror our step, and that code is below and covered in the next segment. And then we run a for loop that checks each existing herd animal to see if we should follow it. If we should, then it becomes our leader and we join its herd. But the logic of that loop needs some explanation, which we'll do in the next segment.